Hello and welcome back to the lab. Today on the bench we have another 465. This one comes to us for repair. I have been told it doesn't work. Some of the pitfalls of running a repair channel is you get a lot of equipment that it's like, oh yeah, it's busted, and then it works. But I have been told that this is non-functional, so we should have some troubleshooting to do. This comes courtesy of the local ham club. And we're going to see what we can do to get this thing running. I don't know much, only that the trace disappeared on it, and we'll go from there. You guys see it as received, so all the knobs and the switches and everything were in the last position used. But I do see already some issues that might cause the trace to go kind of sideways. A couple of those would be we're on channel 2. No, that's okay. But we're on B delayed and normal mode. So if the scope isn't triggering with this switch in this position, we won't actually get a trace on the display. So let's put some power to this. Since I know it was powered up recently, we can be safe to plug it in. And we'll fiddle with the buttons and see what it tells us. Okay, I have the scope powered up. And let us see what happens. Well, good news is we have some life because the scale illumination works, and I did hear that staticky discharge. I'm sure the microphone didn't pick it up, but it was something CRTs did when you fire them up. You'll hear this crackle on the front of the display. That's the high voltage coming in. So I'm relatively sure at this point we have high voltage. We were able to figure that out just by powering it up. So let's put the knobs in a decent position. Oh, the trigger's way out on here. So trigger to center, auto, 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 normal, and nose all the way up. And let's see if we get a trace. Oh, that's not good. Okay, so we have a glow. It's off the side of the screen. We cannot actually move horizontal or vertical, and we have no sweep. Let's see if we can, so that's a clue already. We don't have much sweep on this scope. So let's set it in XY mode, and let's see if our deflection plates are working. Okay, so that is starting to look like we may have a fault in the horizontal section because I can move the trace up and down, and given the way this is fading in and out, I can see that it's actually moving like it's supposed to. However, I do not have a lot of deflection. So first things first, before we do anything else with all of these, let's crack the case off, check the supply rails for shorts, and this might be a power supply, might be something deeper. Okay, the back of the unit is in pretty rough shape. We have screws, we have feet busted out, screw missing here. We do have both screws there. So we will be, regardless, there is a 3D printer, an STL file for these feet. We will be replacing the feet on these before this leaves the lab. But let's continue further. Get out the power screwdriver today with the giant bit so we can get in here and get these screws out. I like the multi-bit screwdrivers and I use them quite a bit, but getting inside these feet can be a challenge with some of the... Wow, that screw's long. Okay, we're out. Nothing there. With some of the multi-bit screwdrivers. This one. And this one. Okay, as in a previous video, I did ground this static mat, and actually just this evening, we have ground points there and in the front of the bench for me to put wrist straps on. In this case, I lifted the ground on the static mat because the 4,000 volt supply on this is on the bottom. So as I have this open, I want the mat floating on the wooden top. So I do not want that grounded at this point. And now, as always, punch it out the front. And that's how we get in. Okay, first looks on this particular unit. I can tell just by looking that we have a very early construction serial number. These diodes are of a higher vintage. The board also not being green. This PCB material is of a earlier production run. So our power supply is going to be in here. Yeah, here are my test points. So let's check for, this one's going to be interesting because it doesn't have all the test points. So let's check for some shorts and go from there. I have a convenient ground here. Obviously the high voltage supply is here, and we don't want to have to go in there too much if we can help it. But given the symptoms of the scope at the moment, I'm very interested in what the plus minus 15 volt rails, the 5 volt rail, and the negative 8 volt rail are doing. And I want to look at those before we do pretty much anything else. Well, visual inspection strikes again. I was curious. I was looking for my ground test point over by the power supply, trying to see if I could locate it. And, well, that can't be good. Where is it? This resistor right here is burnt in half, as well as it shot some stuff out on this ground plane that's underneath it. So this turned into a light emitting resistor momentarily and decided to go away. So this capacitor, given that it's close by, is now extremely suspect, as are any tantalums that are around here, but I am relatively sure that is going to be open. And in case, we can check this out right now. We'll go on that side. No, that is a 21.83 ohm resistor. I don't know what that's supposed to be, but it's not open. Might be short, though. So let's keep poking around for a ground point in here. Oh, ground test point right here, giant bridge. So we'll hook up our negative to the meter, and I'm going to check the supplies real fast, but that's going to need to get fixed. Okay, as always, the supplies in a 400 series scope are to be suspect, just given the age of the tantalum capacitors and some of the ways that they were built. So we'll run through and just ohm out the power rails real quick. Here's our negative, or our positive 15, 171 ohms. Our negative 8, 57 ohms. Our 110, 16K, plus 5, 84. Does this one have the minus 5 volt test point, or does this have the other one? Also, I need to check this fuse, see if this fuse is blown because of that resistor. That could be a problem as well. Dead short, because that's ground. It should be. Alright, where's my... Where is my negative 15 volt rail? I don't know. We'll have to go to the schematic. Well, it turns out to be right about and suspicious about that capacitor. Now I need to lift this capacitor and really check this. So what do we have going on? So here is a schematic of the affected circuit. The resistor that's burned is R1220, which is a 22.1. I need to get the tolerance spec on it first. 21.8, so we are below spec. This might be a pretty tight, since it's specified to a 0.1 ohm, this could be pretty tight in terms of tolerance. But our 8-volt rail comes in, and sweep drive comes in down here. So sweep drive goes right into this, into Q1224. But part of this is biasing Q224 and 234 through this network here, and our affected components are right here where we have a negative 8-volt rail coming in and a bulk capacitor right there. So if we don't have this negative 8 volts, if it's shunting to ground through a shorted capacitor, that'll definitely screw up the sweep drive, because sweep comes in. This is the first amplifier for the sweep circuit, and the main sweep drive amps are over here. So this could very likely explain why we don't have horizontal sweep. So let's test some parts. All right, we'll do a quick ohms test in circuit for this capacitor, because we have ground on this side, positive on this side. That's not looking good. 77 ohms through the cap. So first suspect is this cap, and I'm also going to check out what that resistor is supposed to be. Okay, as expected, I checked the schematic. This is a very high precision resistor. This is a 22.1 ohm, 1% resistor. Even it's out of spec. Regardless if it was out of spec or not, it's been burned, so I wouldn't trust that in a repair anyway. It's going to get replaced. But let's get this cap out of here and see what he says, because I am quite curious as to what might be going on here. Also, this is on the negative 8-volt supply, so this capacitor looks like it's in circuit in reverse. It's really not. The positive side should be grounded because it's using the negative volts, or the negative plate on the negative rail. So this is in the correct orientation for its position. Okay, I've moved you guys off to the side. We have the fume extractor going. I have been told you guys would like to see some more soldering in the videos, so here we go. We will try to do this around the camera, and I will say random things while I'm working. Nope, need a bit of solder. That's not going to heat up fast enough. For some more detail on the solder that I use here in the lab, take a look at the soldering video back in the video catalog. I go into detail about electronic soldering and things like that, well, the solder specifically, and I also have a detailed video on the irons themselves. This is going to need some. Oh, there it moved. And there we go. Well, that resistor didn't do that cap any favors either. All right. Moment of truth. This is not showing as a capacitor. or at least a healthy capacitor anymore. Apologize for the angle, but we're going to test source voltage and measure current. We're going to source 10 volts because that's what this capacitor is rated for. And we're going to current limit at a milliamp. And boom. Oh yeah, nope, that cap's done. The voltage is climbing, so it's recovering very, very quickly, but that capacitor is toast. So here's a better look at the SMU. The SMU's not even on, so the output is off, and the voltage on the capacitor is falling this rapidly. The SMU should be in high impedance right now, so it shouldn't be actually doing anything to the capacitor, so the capacitor is self-discharging. So that one's not healthy. I'll hit the go button again, and we'll watch it charge up real fast. But it's charging that slow too, so we'll let it go up to 10 volts, and then we'll watch the current come down, but it's not. Let's see if we replace that capacitor if our sweep comes back. Okay, orient you guys back on the board. Where's our burnt resistor? There it is. So there's our hole for the capacitor. So now what we're doing is working on cleaning out the holes and not burning myself while I untangle the soldering iron. Done that enough times, too many times to count. I think also for good measure, we're going to test Q224 and Q234. Or sorry, 1224 and 1234. And those transistors are this ganged package right here. So we'll use the peak to check those real fast, just to make sure one of those transistors hasn't shorted. All right, to finish making our capacitor up, I'm going to endeavor not to burn my fingers off. Focus camera, please. Thank you. And we're going to play with a little bit of fire. And I am not watching the camera. I am paying attention to what I am doing. All right. So, in the end, here's our nice capacitor all worked up. Negative side, positive side, with the leads trimmed for soldering. I will, when I get a hot air gun, do a lot more of that work with a hot air gun. Right now, I do not have one, so I am making do with what I have in the lab at my disposal. The plan is, very quickly, to have a hot air station in the lab, because I'm going to be doing some surface mount stuff in the very near future. Or I should say more surface mount stuff. I've been doing surface mount stuff for a while. Kick this back down out of the way. Oh, you're going to be a pain, aren't you? All right, our new cap is in place. This resistor is still maybe healthy enough to sweep, although not at all. We're going to check these transistors next. These are going to pop out, and we'll get the atlas. Okay, going with the DCA Pro for this one. So these transistors are probably going to be very well matched in terms of beta, and they're also strapped together with a heatsink, which means they want them thermally coupled as well. An HFE of 130, that is okay. It's an NPN BJT. And 108, another NPN BJT. So those are testing as transistors at the moment. Okay, for testing purposes, let's see if it sweeps. We'll get this plugged into a different power strip so I don't have to reach over everything. You guys keep an eye on that resistor. Tell me if it gets really hot. Well, we already have a dot in the middle of the screen, so that's going to be, that is going to be a go because I'm in XY mode. I still don't have any vertical. Oh, yeah, I do have horizontal. Okay, I have horizontal control back, and we're sweeping. So we have a line. So here was the fault. We did have some cascade failures. I am not going to leave this on long or leave this like this. That resistor is also going to get replaced. However, I do not have any of those precision resistors in stock, so I am going to have to order some in from the usual suspects. But we are off to a really good start of getting this 465 back up and running. I'm going to speak with the owner the next time I see him. I'll do the resistor before then, so I won't know what his response is. I do not know what his intentions were with this scope. He asked me to take a look at it. If he would like it calibrated and sent back, that's fine. If he's replaced it with something else already, that's also fine too. But I'm not going to assume this is available for anybody who would like it until I get the official from him that he does not want this to be returned. That was up in the air. We've discussed it both ways, so this might come available if anybody's interested in a 465. Obviously, if it does come available and somebody is interested in it, I will run it through a full calibration before I get it to its next owner. If the current owner of the scope is interested in getting it back uncalibrated, I can do that. And if he would like it back and have me run it through a cal process, we can do that as well. But for now, I got to order some parts, and I have a better working scope. So you guys are going to have to wait, or you guys are not going to have to wait. I'm going to have to wait a couple of days, especially given the day that it is. We're getting into the Thanksgiving weekend. We're getting into Thanksgiving week as I'm recording this, so the delivery services are going to be very up in the air as to when stuff's going to be coming in over the next week or so. With that, let me get some stuff ordered, and I'll bring you guys back when I have some parts. All right, well, we like our job so much we get to do it twice. I made a mistake, and I put the wrong part in right here for this repair. This is a 10 microfarad cap. What I pulled out was a 1,000 microfarad cap. So we have a 1,000, come on, 1,000 mic by 16 volt. This was only a 10 volt cap, so we'll just pop this off real quick and clean out these holes again. I still do not have the resistors yet. Those will be coming soon, I'm sure. Okay, polarity is correct. Everything is good. We'll fire up the scope again, make sure it's still sweeping. I expect it will. And I'm supposed to get resistors tomorrow, so when those show up, we'll come back in here, fix the resistor, and then we will call it a day. I am still waiting to hear from the owner what they'd ultimately like to do with it, so we're still working on figuring that out. And we'll fire it up for a power on test. Survey says we have sweeping, so everything looks good there. Cap's not boiling over. No excitement, so couldn't ask for much more. So one other test we could do on this capacitor is to check its ESR. I did a video on what is this ESR stuff anyway, which is back in the video queue. So we have an Atlas ESR tester. This is going to do an AC test on this capacitor versus a DC test, which we did before. But if we test this, our cap's measuring a little high, 1274, which is to be expected given the way this tester works. That's where the DC leakage is showing up, which is why this cap failed. However, the ESR on this capacitor, 0.20, so 200 milliohms, is not horrible. Could be better, but not awful, especially for a 1,000 microfarad capacitor. So for ESR, this cap is okay. For DC leakage, this cap is toast. Okay, once again, today is tomorrow, and we have feet off of the 3D printer. I did not have black filament, so gray will have to do. But we'll get all this stuff cleaned up. These actually separate real nice from the build plate. I will need to clean up the build plate after that. And our resistors came in. 22.1 ohm, 1% resistors, bulk, nice blue precision metal film. So now what we're going to do is we're going to tackle this resistor right here. Fume extractor's on, everything is good to go. Soldering iron is warmed up. There we go. Move these out of the way so we don't melt the feet. And pliers. The scope has been off for quite some time. And nothing to worry about. And by quite some time, I mean several days. Oh, we have a nice blowout on that one. Let's get some alcohol and see if we can't clean this up a bit. Zoom out for the cleaning, 99% isopropyl. If my pump works. Oh yeah, there it goes. Just had to prime. Haven't used a bottle in a while. Oh nice, the burn mark cleaning off the trace. No problem. And we actually have no trace damage. Everything looks good. Let's zoom in on that, take a quick look. And as we can see, our staining is gone. So we just need to lead form some resistors, or some resistors, a resistor. To that, we bought plenty to keep in stock in the lab, just in case I need these again. Resistors are cheap, shipping is expensive. So the reason for moving the scope and flipping it over is because this resistor wants to tilt fall out of the hole, and I do not want to fight with this too much while it's on the pad, because I do not want to burn out. I do not want to burn out the pad on the board. Too much heat from the iron will soften the glue holding the trace down to the PCB and will lift it actually off the PCB, and that's what I don't want to have happen. So this way gravity is helping me as opposed to fighting me, getting this thing in there. Okay, get my Q-tip real quick, and we'll get the flux off. And there we go, repairs in real time. All right, we have a bit of signal coming in from the HP200 CD. Let's go ahead and fire this up and give it a smoke test, see what we look like. Very bright, don't need that. And we're going to go to AC, back this down. We have a trigger, and there we go. Look at that. We have a beautiful sine wave coming from our 200 CD. So at this point, this is ready to go back to its owner. I do not have any specific instructions as to what he would like to do with this unit yet. We're going to talk about that. We're going to talk about what he'd like to do at the next ham meeting. So this might get an alignment. This might go back to him. This might be available. I do not know yet, but I will know shortly. But for right now, the scope is finished and repaired and ready to go back. I have not gotten instructions to calibrate it or do anything before sending it back. So given that this is a customer unit, this is all that I have been instructed to do. So that's all that we're going to do in this video. But I will replace the feet because they were in really rough shape. We'll get some better feet on there and provide those back to the owner. Okay, a quick check of the time marks from the rubidium stabilized TG501. These are 1 microsecond time marks. We have it lined up here, and as we see, it deviates a little bit coming over here to the edge. So in tweaking the adjustment, I have taken a look. The time base is off by 0.9%. Not too bad for one of these scopes. So everything is all well and good. I'm going to report back to the owner and go from there. But so this may or may not show back up on the bench. I'm not 100% sure yet, but repair is complete and the scope is sweeping again. Everything looks good. So thanks for taking the time and watching the repair on this 465. As always, I will see everybody in the comments in between videos, and I hope this helped. More is always on the way, and I'll catch everybody in the next video.